What's up, brother? Today, we're going to be doing the pretest for lines and planes. Question number 19, intersection of three planes. Let's get going, brother. So, in this, we have three planes. But, to get started, we have to indicate if they're parallel or not. So, to do so, we have to find if there's any way to eliminate all x, y, and z values. In this case, we cannot. Indicating that these three planes are not parallel distinct, which has 0 points of intersection, and it's not parallel coincidental, meaning that has infinite points of intersection. So you can start off by eliminating either the x, the y, or z value of two planes, and then start solving from there. In this case, in planes 1 and 2, you can eliminate the z values, positive 2 and negative 2, giving you x and y to remain. So by adding planes 1 and 2, you can get rid of the z's because 2 plus negative 2 is 0, giving you 2x plus 2y equals 4. So make your parametric, put your x, y, and z in, and then you can actually start to solve. So since you have an x and y value, you can substitute either the x or the y for t. In this case, we will be substituting the x value for t, giving you x equals t in the parametric. Then you will have 2t plus 2y equals 4. Isolate for 2y, giving you 2y equals 4 minus 2t. Divide everything by 2, which gives you y equals 2 minus t. Place that in the parametric above. Then, using one of the two planes previously used, and the x and y values that you received, which are in the parametric, you can solve for the z value. So, with your plane, you can implement the x and y, which gives you t minus 10 plus 5t plus 2z equals 10. Isolate for 2z, or I guess in this case, isolate for z, which gives you 2z equals 20 minus 6t. Divide everything by 2 again, which gives you z equals 10 minus 3t. There, you have your parametric. Using this parametric, you can plug it into the third plane, which wasn't used, and then you can solve for your point of intersection. Plugging the parametric into the plane will give you 8t plus 10 minus 5t plus 10 minus 3t equals 20. There, you can combine like terms, the t's and the numbers, which will give you 0t equals 0. Wowzers. That gives you a point of intersection at a line. So, how do you find this line? Well, you can use your parametric. Because your parametric is the line equation, you can rearrange your parametric into the line, which gives you a line at, or the line of intersection at r equals 0 to 10, which comes from the numbers within the parametric that aren't with the t. So 0 for x, 2 for y, and 10 for z, plus t, 1, negative 1, negative 3, which are the numbers which are with the t's. So 1, negative 1, negative 3. Therefore, your line of intersection is at r equals 0 to 10, plus t, 1, negative 1, negative 3. Now, you can solve it with a matrix as well. Matrices are pretty cool, because using the RREF, you can get a line of 1s, or diagonal of 1s, and then triangles of 0s. That will give you your point of intersection. To start, you're going to want to put your planes into the matrix, and then, using said matrix, you can start solving. To start solving, you want to try and get as many 1s and 0s as possible. So to do so, in this second matrix, you can combine row 1 with row 2, giving you 2, 2, 0, and 4. Dividing those by the common factor of 2, or the common term of 2, you can get 1, 1, 0, 2. In the second row, you can subtract row 2 by row 1, giving you 0, negative 12, 4, and 16. If you divide all those by the common factor of 4, you can get 0, negative 3, 1, and 4. And then row 3, you can combine row 3 and row 1, giving you 3, 0, 1, 10. That's been divided by 3. So, as you can see on the board, you have the next matrix. Using this, you can start to solve further. So, we're going to start with row 2. If you multiply row 1 by 3, and then add it to row 2, as shown here, you can get 3, 0, 1, 10. Wait, what does that look familiar to? I think it looks familiar to row 3 in the previous matrix. Putting that, which is important, because if you bring row 1 and row 3 down, don't make any changes, which is allowed, you can then subtract row 2 by row 3, giving you a line of zeros. 0, 0, 0, and 0, which is indicating that there's a line of intersection. We have a line of intersection, but how do we find it? Well, go back to our previous matrix. Pinpoint any of the rows that give you an x, y, and z value, which are solvable, and in this case, row 1 and row 3, and then you can start solving for the x, y, and z values. Write a parametric, x, y, and z. That will be used in a second. Then bring the first row down, x plus y equals 2. So you can implement t for x again, so you get t plus y equals 2, and then solve for y. Bring the t to the other side, you get y equals 2 minus t, and put that into parametric. Then you have your third row, which is a 3, a 1, and is 10. The y is not needed, so you have 3x plus z equals 10. You can then put the t in for x, giving you 3t plus z equals 10, and then solve for z, which gives you z equals 10 minus 3t. Put that back into the parametric, and as previously stated, the parametric is the line equation. So for this, you have a line of intersection which occurs at r equals 0 to 10, plus t, 1, -1, -3.